All right, so in this video, we're going to look at this concept of repetition, also known as looping. So let's get started. Okay, so let's talk a little bit about this idea of iteration, because you'll often hear this term in conjunction with repetition and looping structures. And basically what iteration means is it's the act of repeating something. So when we talk about repetition or looping, we're wanting to repeat some particular operation or set of instructions. So for instance, we may have a list of contacts in our cell phone. We may be interested in doing the same set of operations to each one of these contacts here. And so we can think about iterating over each contact and repeating some particular operation. So we'll do the same operation of Bob, Charlie, Chris, and Rachel. Maybe it's simply just updating their area code. Maybe the area code changed for each one of these contacts. Another example that we may look at, and it may be a little bit easier to grasp, is this idea of iterating over each pixel in an image. And so when we talk about a pixel or a picture element, it's just simply a little dot that's composed of some color. So you could take a particular image that was originally color, and you could iterate over each single pixel. And they're very, very small dots, right? So we could go through each one of these pixels and do some sort of transformation, some sort of calculation, where we change some particular color to its grayscale equivalent, so ranging from white all the way to black and then gray, some form of gray in between. And so this particular image here, it looks like we're halfway through the process of transforming this color photo to a grayscale photo. And so the way that occurs behind the scenes is that we have to iterate or repeat some operation for every single pixel in that picture. So this is just a couple of examples that we can think of in terms of using this idea of repetition. All right, so let's take a look at a specific example using some C++ code. So we have an example over here, and it's a fairly short example, but we can see all the parts that we've discussed dealing with the while loop. So this Boolean expression part is just simply this part right here in parentheses. So we have while, open parentheses, I, less than 100, close parentheses. So this is just our Boolean expression, the thing that we want to test to see if we can enter into the body. So all of this right here is defining the body of our while loop. And we can have our statements that we discussed before inside this open brace, close brace that defines the body. All right, so what's going on here? Basically, we have a variable I, and it's been initialized to the value of 0. So whenever we first come here to this while some condition, while I is less than 100, I is going to be 0. So I'm going to make a little bitty table over here and keep track of maybe the value of I, and also keep track of what we're outputting, because it looks like in the body of the while loop, we're actually outputting something there. So initially, I is going to be 0. So since I is 0, and 0 is less than 100, we'd be able to get into the body of the while loop here and execute these statements. So we'd have, do a cout, and we'd have I is 0. And then we'd increment the value of I. So this time, I is now 1, and we would come back. So once there's no other statements left to execute inside the body here, we'd come back to the top and test this Boolean expression again to see if I is still less than 100. And now since I is 1, it's still less than 100, and we'll come back into the body and do this statement again, except this time we'll have I is 1. And so we continue this operation, so we keep on going. And finally we would get to I being 99. So you can imagine that maybe we had just performed this statement here in which we had I was 98, and we outputted I is 98. So we just did that operation there. And then we increment I to 99. So we're looking at this case here where we just incremented I to 99. And now we're going to come back and do this test here. Is 99 less than 100? Yes, it's less than 100. So we'd have I is 99. And then what would we do? We would increment I one more time. So we'd increment I to 100. But this time, whenever we come back and execute this statement here, we'd find out that 100 is not less than 100, and so we would not output this statement anymore. So it would result in us actually executing the body of this while loop 100 times. The first time we would output I is 0, and the last time we would output I is 99. And I would get incremented to 100, but you would never actually see that being printed out because that output statement is occurring before we actually do this increment. And this statement here, maybe I should have said that initially, is just equivalent to I is equal to I plus 1. So this here is just a shortcut for saying this over here, I is equal to I plus 1. So you're probably saying, oh, well, that makes maybe a little bit more sense in terms of talking about C++. You can think about maybe C++ being one more, the next iteration of C. And that would be a correct thought. So that's basically what's going on. As soon as we get kicked out, meaning that this statement is false, so I is no longer less than 100, then we would not be able to enter into the body, and we would just come down and execute this other code, whatever other code we may have there. It may turn out that there's no other code, and just the program ends at that point in time. So this false over here would be associated with this other code that we'd execute after the while loop. So that's basically it. The while loop's a pretest loop. We know that we have to test the Boolean condition before we can ever do the execution of the body a single time, and we'll keep on executing the body as long as this is true. Okay, so let's take a look at one of the other looping structures that's provided to us by C++, and that's the for loop. And the for loop is basically a convenient structure. So in our previous slide, we actually looked at the while loop, and in that particular while loop, we knew that we wanted to execute maybe this code 100 times. So we set up some variable here and initialized it to 0. Our loop continuation was set up so that I was less than 100. And we incremented I by 1 each time that we went through the loop. So this was actually designed where we knew that we wanted to do this 100 times. And we may want to do, if we want to do something a known number of times, as opposed to using the while loop, we can use this convenient structure called the for loop. And so we can transform all of this stuff here into what we have over here. So here we have the keyword for, open parentheses, then a bunch of stuff, close parentheses. And this is what we call the for loop header. So this is simply the for loop header. And the for loop header has 3 parts to it. The very first part that we see here before the semicolon is what we call the initial statements. So this is the initial statements. And here is what we call the loop continuation condition. Abbreviate condition and continuation and condition. And then finally we have what is called the post statements. Okay. And what you'll see is we had the same sort of stuff over here with our while loop. So this initial statement here was what we had above the while loop. The loop continuation condition is just simply the same exact Boolean expression we had over here. And then finally this post statement was what we had at the very bottom of our while loop. So effectively what happens here is when we first enter into this bit of code for the for loop, we'll do whatever we have here. In this case, we're just simply initializing the variable, declaring and initializing the variable I to 0. So that only happens the first time that we come into this particular for loop. All right, so as we loop back around and test the loop continuation condition, we don't go back and reinitialize the value of I back to 0 each time through. So this is only done when we first come into the loop. Okay, so you can almost imagine it being before the loop or the for loop header, just like what we had here in terms of the execution. And then we have the loop continuation condition, same thing we had over here, and then post statements. So we can imagine this little statement here being the very last thing that gets executed inside the body. So that after we execute all the statements, in this case we only had one statement, then whatever post statement we have over here would be executed as the last thing, just as we had over here. So again, the for loop, not too different from the while loop in the sense that it's a pretest loop, meaning that we have to test this loop continuation condition before we ever get into the body here. So the for loop may execute 0 times, just like our while loop may execute 0 times. Again, this is a convenient structure. It's not actually required. We could still do all of our repetition structures, or all of our repetition needs could be fulfilled by the while loop without ever using the for loop. It's just a nice convenience that we can kind of wrap everything up here in the for loop header. And don't forget your semicolons here. So there is a semicolon here. Oops. There's a semicolon here, and there's also a semicolon here. No semicolon after the post statement, just a close parentheses. Okay, so let's take a look at the last looping structure, and that's the do while loop. Now, the do while loop is a little bit different than our while loop and our for loop in that it's a post test loop. So what does that mean? Well, if we look at our diagram over here, we'll see that we can execute the statement or statements one time before we'll ever test that loop continuation condition or that Boolean expression. So we execute the statement one time, test the loop continuation condition, and then if it's true, we'll come back and execute that statement or statements again. If it turns out to be false, then we'll go down here and execute some other code. So over here we have an example of a very basic do while loop. So we have some variable here, radius, that we've declared and initialized with the value of -1. And then we have the actual do while structure. So you see that we have this keyword do, open brace, close brace, while, and then some Boolean expression here. So you can see that we actually execute the body of the loop one time before we ever look at the condition here to see if we can execute it another time. So do this while this is true is basically the way we'd look at it. And so in this case, we would ask the user to enter in a radius, so prompt them, then read it, and then test to see if that radius was less than 0. The big idea here is we want to force the user to put in a valid radius. If they put in a number less than 0, then we know that we do not have a valid radius. We could have a radius of 0, but we couldn't have a negative radius. So this is a nice structure. So anytime that you have a situation in which you want to execute a statement or set of statements at least one time, then think about using the do while loop. In the case of knowing exactly how many times you want to execute, you probably want to think about the for loop. If you don't know how many times, and you may not even be executing the statements even one time, then think about using the while loop. So that's our basic 3 looping structures that we're going to look at here for C++.